Hello friends, welcome to SS tutorial. Today we'll discuss about uniform circular motion. When a particle moves with a constant speed in a circular path, its motion is said to be the uniform circular motion. What is the direction of velocity at any instant in circular path? The velocity of a particle in a circular motion is variable, or the circular motion is accelerated even though the speed of particle is uniform. Just remember that here. Speed is uniform, but the velocity is changeable. That's why its motion is accelerated motion. Look at here how the direction changes. Just look at my figure. Just I'm rotating it. When it rotates to position A and B, the direction of velocity at the point A is downward, whereas the direction of the velocity at point B is upward. Both are in opposite direction. Similarly, again we rotate it to position C and D. At position C, the direction is towards right, and at position D, the direction of velocity is towards left. That's why at every instant in circular motion, particle velocity of the particle is different because its magnitude is same, but it changes the direction. That's why the velocity is variable. Due to variable velocity, the uniform circular motion is called as accelerated motion. Now we compare the uniform circular motion and uniform linear motion. What is the difference between uniform linear motion and uniform circular motion? In uniform linear motion, just look at here, direction of the velocity is same in every part of the motion. Hence, both speed and velocity are uniform in this motion. Okay, but in uniform circular motion, direction of the velocity change in every part of the motion. Hence, speed is uniform, but velocity is non-uniform in this motion. Friends, we know clearly velocity is a vector quantity, but speed is a scalar quantity. That's why velocity has two components. That's one is magnitude, another is direction. But speed have only one component, that's only magnitude. In uniform circular motion and uniform linear motion, in both the condition, the magnitude does not change. That's why its speed is says to be in uniform in both linear motion and circular motion. But in linear motion, the direction does not change through the motion. But in circular motion, the direction of the motion will changes at every instant. That's why its velocity is variable, but speed is uniform in circular motion. That's why it is an accelerated motion. But in case of linear motion, the direction of the velocity does not changes. That's why its speed as well as velocity both are in uniform motion. Uniform motion. That's why it is a non-accelerated motion. Clear? Now, the main part of the circular motion is centripetal force. What is centripetal force? In circular motion, at each point of circular path, the particle continuously changes its direction of motion, cannot be brought without a force. Thus, the motion in circular path is possible only under the influence of a force which is termed as the centripetal force. At each point of circular path, this force is directed toward the center of the circle. Okay, we clearly know that the direction of any motion does not change unless we apply external force on it. It is clear. That's why, but in a circular motion, the velocity changes its direction every instant. It means there must be some force act on this which is responsible for change of this direction, and that force is known as the centripetal force. And this centripetal force is always acted towards the center. Okay, and I give you some example. The electrons revolving around the nucleus. There is a force of attraction between the electrons and the nucleus, and this force of attraction converted to centripetal force, and electrons started revolving or rotating around the nucleus. And the same principle also applied in our solar system. All the planets, and there is a force of attraction between the planets and sun, and this force of attraction converted to centripetal force, and all the planets, that's why all the planets revolves around the sun. Okay, then another important part of circular motion is centrifugal force. This centrifugal force, a force acting on a body away from the center of circular path, is called the centrifugal force. Okay, it is the force just opposite to the centripetal force. Centripetal force acting towards the center, but centrifugal force is acting away from the center. Okay, just I give look at my figure. Just I explain you. I stand two persons. One person's at the position M and another person at position A. I stand two persons. Okay. These two persons, A is inside the motion and M is the outside the motion. Clear? So the person standing at M, okay, it is just I explain you. It is a merry-go-round. I just explain with a merry-go-round. It is a merry-go-round. One person stand out of the merry-go-round at the position M, and another person is stand at inside the merry-go-round at position A. Now, when we start revolving the merry-go-round, the person stand outside the merry-go-round at the position M. He feels that the motion is circular, the ball is rotating. But the person standing at the position A, the direction does not changes. It is always front of the person, and it is start rotating. Okay, so it is a this shows that the motion does not changes and the direction does not changes. When we start revolving, when the merry-go-round starts revolving, a tension creates between the string. Just if we revolve a string by if we tie a stone to the thread and we start to revolve it, when our thread is loose, it can't revolve. Okay, when we start revolving, there is a tension created between the center and the stone, and this tension act on the string, and this tension is always towards the center. Okay, and the centrifugal force is just opposite to the center, then opposite to the tension. Okay, when it rotates, if the string breaks down, then your stone moves in a straight line, but the person stand at aim position, he feels that the most the ball or the stone moved away in a straight line, but in the person standing inside, just give the below figure, the person standing at position A, he feels that it is always straight to him but going away to him in a straight motion. Okay, so moreover, if I'll say to you, the centrifugal force is not a real force, it is a fictitious force. The only force involved here, the force of tension in the string acting towards the center. That's the centripetal force. A force which is really does not exist, but it considered to describe a certain motion. Okay, so the centrifugal force is also called a fictitious force. Okay, okay, thank you for watching.